All right, let's do our AP Tester Trio. Here we were talking about this one talked a lot about sampling distributions, okay? So making sure that we understand this here, where this one has our population standard deviation, this one has the standard deviation of one sample, and then this one has the standard deviation of many X bars, a whole bunch of X bars, so it's that thing there. So this was a tricky problem. So what we have here is that I can see that the standard deviation of this sampling distribution is 15. So solve this right here for S of X. That's what you're solving for. So I can see that this is 15, okay, and that N is told to me to be 25. So see, that's what I put in. I put 15 in, and I put the square root of 25 in, which is 5, and then I solved for the S of X. Very tricky. Man, that one right there makes you know what you're talking about. Okay, very big deal. All right, moving on. So then here we have got this next one, which also we are talking about what is this saying about the central limit theorem. So by definition, the central limit theorem says if n is large enough, then it does not matter the shape of the population, the sampling distribution will be approximately normal. Okay? And so then that's what we have here, the distribution of the sample means. What's down here are all of these X bars. That is the sampling distribution of the sample means. Okay? Of the number of recharge cycles is approximately normal because why? Because the sample size is large enough, because sample size is greater than. Not the number of recharge cycles. Okay, because what is this blue thing about? It is a sampling distribution of X bars, not a distribution of the number of recharge cycles. I think that would be the population. Okay, or just one sample. All right. Now, E is good, but the problem, so this distribution of the sample means of the number of recharge cycles, but it's not because the population average is 400. No, it's because the sample size of 100. All right, and our last one, number 3. Lots of stuff going on here. Whoa, I have a lot of things written there. And you know what? You might have been able to do this problem a lot easier than I did. Okay, mine seems to be pretty complicated, and sometimes I get caught up in doing things textbook wise instead of some common sense wise. But I'll go ahead and show you my way. So I drew this picture of what we know. We know that the mean is 84.07. We know that 100 has 0.064 above it. So then I found out, well, what z-score then does 100 have? So I did the inverse norm of the area below, 0.936. So the z-score for that was 1.52. Now, this problem was about the average. So was it why did I not do t-scores? Oh, because, well, so did they tell me the population standard deviation? Okay. Oh, okay. This isn't about samples. This is about just finding one result. Okay, so this is not a sampling distribution. This is the population. Okay, so we're not doing t's. We're doing the population. That's approximately normal. Okay, so then I have 1.52. So from that 1.5, so here's my second step. I used 100 minus the mean over this unknown standard deviation is located at 1.52. So I solved and I got a standard deviation of 10.48. So now that I have a standard deviation of 10.48, now I go and find this thing here. What's the probability that it will be at least 90 feet? So I need to go find the z-score for 90 feet. So I do the 90 minus the mean over the standard deviation, and then I norm CDF from that 90 feet and above. Okay? So lots of steps on that one. Wow, that one was a hard one. Okay, moving on. This last one I'm going to do separately. It was a 2018, the lowest scoring AP free response question of all time. So I'm going to do that one separately and talk to you about that. So you